Well, we'll take images and spectra in the ultraviolet and near ultraviolet part of the spectrum of the sun. And that's a type of light that we usually cannot see from the ground. The Earth's atmosphere absorbs all of that, which is a good thing for us, otherwise we'd have a really bad sunburn. The ozone layer of the Earth absorbs that light. And so what we need to do is, if we want to look at that region on the sun, the interface region emits mostly that type of light, we need to put our telescope above the Earth's atmosphere. And we do that by launching a satellite, and it flies about 400 miles above the Earth's surface. It's not going to fly to the sun, it just orbits the Earth, and it has a telescope. The telescope takes the light, and that light gets fed into a spectrograph, which splits up the light into its colors. And that light actually just ends up on a detector, a camera, kind of like what you have on your phone, except a little bit more expensive. And that data gets processed by a computer, downlinked through essentially radio with the ground stations, and then we get the data on our computers. So what we do with that data is we combine it with data from other observatories, either other solar satellites that orbit Earth or even the sun, that look at the sun, but that look at different parts of the sun. And we combine all of that information with computer models. And the computer models really help us understand this very complex region where so much of the solar activity is happening. It's a very complex region, and that means that we need essentially supercomputers. We use the NASA supercomputers to model a piece of the sun within our computer. We also use ground-based telescopes. These are telescopes that are usually in the middle of the ocean where there's very nice weather and very stable air, and they allow us to look at different parts of the sun's atmosphere, more the surface of the atmosphere, which drives a lot of the activity higher up. And so a combination of all of these facets of the investigation will allow us to understand how the gases are heated and cooled in this region.